In this video, I will explain how when you solve different equations, you could get some different kinds of conclusions. So for example, for this equation, we know we can ask ourselves what plus 7 equals 9, and that would be where x equals 2. Because what we would end up doing is subtracting 7 from both sides. Or you can just think what plus 7 equals 9. And so in this case, we got one solution. So you won't always get just one nice solution. I mean, you sometimes will get 2 or 3 or 4 solutions, but we would look at that later in more advanced math courses. In my previous videos where I was explaining how to solve rational equations or equations with fractions, we would come up with one answer. Okay? But we don't always just come up with that conclusion where there's one answer or 2 clear answers. Sometimes we come up with no solutions or an infinite number of solutions. So I'm going to show how equations might work out in that way. So here's an example, negative 3w plus 5 plus 5w equals 2 times w minus 6. So the first thing we do is we would distribute this negative 3 to each term inside the parentheses. So we'd have negative 3w minus 15 plus 5w equals 2w minus 12. And again, I'm going to mention how to write math work appropriately. And that's to show and write down the original problem, and then right under it, write how that equation changes when you evaluate one thing at a time. Well, we did 2 things at one time, but that's okay. They don't affect each other. So now you look at what you have, and if you have like terms on the same side of the equal sign like this, you combine them. So we're just going to do that. So negative 3w plus 5w is 2w minus 15, and then we bring down everything else that we have in the equation, equals 2w minus 12. Now what we want to do is get the w terms on the same side of the equal sign so that we can combine them, and we want the numbers on the same side of the equal sign so that we can combine them. So we just work on doing that. And again, with this type of equation, you could choose to move the 2w over, you could choose to move the negative 15 over, you could choose to move 2w over to this way, we could choose to move the negative 12 over to this way. There's literally 4 different things you could do here. 4 different students could do each of those, and they should come out with the same conclusion. So I'm just going to pick to move this 2w over to this side to make it disappear from the right side and appear to the left side. So I'm going to write down the equation and space things out a bit so you can see what I do. So the way I'm going to move that 2w over, I'm going to make it disappear from here by subtracting 2w. I do what is needed. That makes 0. And I have to do it to this side too. Subtract 2w from both sides. So then I just evaluate whatever it comes out to be. 2w minus 2w, that's 0. 0 minus 15 leaves minus 15. Equal sign. 2w minus 2w is 0. And then I've got minus 12 left. So this is just how the algebra worked out. You know, this is how it happened to work out. This is so weird, right? Negative 15 equals negative 12. That's not even a true statement. How can that number equal this other? It just doesn't. Negative 15 equals negative 15. And so this is an untrue statement. So when you get something like that, when your equation works out like that, and you don't have a clear x equals 2 or w equals some number, then what we say is that this is no solution. So in your homework program, MyMathLab, Alex, whatever you're using, there might be optional like multiple choice, and you could choose one of these. The answer would be no solution. If you're handwriting your work, you put no solution, and that's the answer. That means that in this equation, it's set up such that any number that we plug in for w, no number will work and satisfy it. So now I will do another problem. Let's see how this one works out. Negative 4 times y plus 1 plus 6y equals 2 times y plus 2 minus 8. So again, we're going to distribute the negative 4 to each term inside the parentheses and distribute the 2 because these terms inside the parentheses are not alike, so we can't combine them. And there's nothing else to do but that. So negative 4 times y is negative 4y. Negative 4 times 1 is negative 4. Write down everything else. And then 2 times y is 2y. 2 times 2 is 4. And then the minus 8. And if I write this line right under this line, I'm likely not to forget accidentally one of these terms. Again, we happen to have like terms right here, so we'll combine them. They're on the same side of the equal sign. And I guess we'll be able to combine these as well. So negative 4y plus 6y is 2y minus 4 equals 2y, and then 4 minus 8 is minus 4 as well. So you can work to get the y's on one side and the numbers on one side and combine them, or you can kind of recognize your answer right here. If you have a true statement, I mean, you have 2y minus 4, of course it's going to equal 2y minus 4. But I'll go ahead and move the 4 over to here just to kind of work it out. It's kind of extra work to even do this, but I want to really show you what will happen. You can move any four terms, any one of the four terms at this point over, the 2y over, you can choose any one. I'm just choosing to make this disappear from this side and appear over here. And the way I do that is by adding 4 to both sides. So then what I'll have is this will be 0 and I'll leave 2y, because 2y plus 0 is just 2y. And this happens to add up to 0, so 2y is left as well. I mean, basically we have a true statement. There's really no reason to do any more work from this line on. You got a true statement. When you have a true statement like that, and it's not y equals 1 or y equals, some number. Even 0 is okay if y equaled 0. But you have something like this. That means all real numbers is the answer. And you have if you're talking about all real numbers, it's an infinite number of solutions. So if you're working with multiple choice or you're handwriting this, I think you could write either one of these as a conclusion. So you can see when you solve an equation, you might not get one clear answer. You might get no solution, or you might get all real numbers or infinite numbers, I should say. Number of solutions. Okay, so this is the conclusion right here. And we'll do a couple more. So what if we have negative 3w minus 15 plus 5w equals 2w minus 12. So this is what we have. And so we look for like terms on the same side of the equal sign, and here's a couple, and we can combine those. So negative 3w plus 5w, that makes 2w. So we have minus 15 equals 2w minus 12. Oh, I think that was the previous problem. So actually, I guess I just have one example for each of that type. So you can see that what I did before was add 15 to both sides. I'm just kind of repeating on the problem that I worked before. There was an original problem up here, and then it turned into this problem. I already worked this. So 2w minus 12 then plus 15. And this is 0, so 2w equals 2w plus 3. And so what will happen is, so I add 15 to both sides. I need the w's to be together. I'm just working it a different way. I think last time I moved the 2w over this way. I decided here to move the negative 15 over this way. So 2w, let's say I'll make this 2w disappear on that side and appear on this side. I would subtract 2w from both sides to make that happen. And so let's see what this comes out to be. So this would be 0 equals 0 plus 3, which is 0 equals 3. And that's not a true statement, so that's where we would have no solution as well. So the first problem that I worked out, I actually did something different than I did here. And so to show you that problem worked out again, I suppose, which I thought it was a different problem, but it's the same problem as the first problem I worked out. I just did it differently. I'll still get no solution. So if you have an untrue statement, a statement that's not true, one number cannot equal another number. You know that equals means is, and is equal to. So you would get no solution when it looks like that.